There is only one question that comes to mind when I see this machine. Why did they make this? Not only does this machine in Scotland lift about 300 tons 35 meters up into the air, it does it while using the same amount of electricity it takes you and me to boil a kettle. 8 kettles to be precise. Now, the first time I heard that, I genuinely thought there was something wrong with my ears. But it turns out it's just physics, and a couple of mad lad engineers stubborn enough to actually build it. So sit back and relax, and let me tell you the story of the Falkirk wheel. My name is Maddie, I'm a civil engineer. I studied at the University of Amsterdam and I've been working in the field for years. And I've always had a soft spot for these huge, ambitious projects. And here's the thing about big projects. To really understand one, you must go back in time. So let's just do that. About 200 years ago, Scotland had a bit of a problem. You see, they had 2 major cities, Glasgow and Edinburgh. These big cities needed materials like coal, iron, and people. And the best way to move all of that in those days was by boat. So the Victorians came up with an idea. They told some poor buggers to start digging. And they took all the credit, of course. 2 canals were built, the Forth and Clyde and the Union. They were made to connect the east coast to the west. There was just one tiny itsy bitsy problem. The 2 canals didn't meet at the same height. The Union Canal sat about 35 meters higher than the Forth and Clyde. And that 35 meters, that's an 11-story building. You don't just roll a boat or a truck or whatever up 11 stories. So they built a flight of locks. No, not those kind of locks. Those kind of locks. 11 to be precise. Separate water chambers that would each rise or lower a boat a few meters at a time. And guess what? It worked. But going up or down was a full day trip. Brutally slow. Now, because it took a lifetime to go up or down, they tore it down in 1933. Smarter, faster ways of moving things had arrived. And the route just couldn't compete with the railways. The trains had won. And a system that took human beings decades to build was simply erased. Forgotten. And for 60 years, that was it. The 2 canals just stopped existing. Dead ends pointing at each other across a gap. If you wanted to take a boat from Glasgow to Edinburgh, you simply couldn't. The link was gone. I think about that quite a lot, actually, because we tend to assume that things we build, like infrastructure, is very permanent. That once something is built, it stays. But it doesn't. Things rot, things get abandoned. We move forward as human beings. Something that is very obvious to us right now that we have, in a couple of decades, might be left behind. But sometimes the hardest engineering job isn't building something new. It's having the nerve to bring something back from the dead. So fast forward to the late 1990s. While some engineers were busy making sure that the world's computers wouldn't shut down at midnight, others wanted to build something special to celebrate the coming of the new age. And one of those special ideas was to bring back the canals, connect them back together. The project was called the Millennium Link. £84 million to reopen the whole route across Scotland. And almost all of it was quite straightforward. A dredge here, rebuild some banks, routine things, routine work, except for one spot. The 35-meter gap. Now they could have just rebuilt the staircase full of locks, like on the Cane Hill flight, also here in the UK, where they built 29 of them. That would have been the safe option. But the engineering team made a decision, one I deeply respect. They decided that the connection point shouldn't just work, no, it should be a landmark, something that announced loudly, proudly that Scotland still has bold things to build. So they opened the idea buffet. Some genuinely wild ideas got thrown at the wall, and the one that stuck might be the strangest of all. Not a staircase, not a ramp, but a giant rotating wheel with arms. One that would pick up boats out of the lower canal and swing them through the air in a half circle and set them down gently 35 meters up. The world had never seen anything like that, and to this day, it's still the only one on Earth. Okay, put your hard hat on. Let me show you the trick, because this is where it goes from a pretty cool idea to a genuine genius one. The Falkirk wheel has 2 arms. At the end of each arm is a gondola, basically a giant bathtub full of water. And both of those bathtubs weigh about 300 tons each, so 600 tons in total. But because the weights are the same, the whole structure stays in perfect balance all the time. To move the boats, the thing rotates 180 degrees. But here's the question that should be bugging you right now. How do you spin 600 tons without an enormous, powerful, giant engine? And the answer is about 2,000 years old. Archimedes came up with it. When a boat floats into the gondola, it pushes out a volume of water that's exactly the same as the boat. A 50-ton boat pushes out 50 tons of water, which spills back into the canal. So the gondola weighs the same whether there's a boat in it or not, which means that both gondolas always weigh exactly the same. The whole machine is perfectly balanced, permanently. And a perfectly balanced object doesn't fight gravity, it just needs a little push. And that push is a set of small hydraulic motors using 1.5 kilowatt hours for a half turn. The same energy as boiling those 8 kettles to move 600 tons. I've designed systems that use more power to open a door. The first time that math clicked in my brain, I actually sat back in my chair and I was just like, this is so elegant. They didn't beat gravity, they used it to their advantage. It's almost like, I don't know, some kind of kung fu stuff. Honestly, they turned the problem into a solution. And if you're the kind of person whose brain just lit up at the end, there's like, well, wait, what? That's it? Then honestly, you're my kind of people. So if you want more stories about the impossible things that humans have designed and engineered, hit subscribe. Okay, right back to Scotland. Building it was its own kind of challenge. The wheel was assembled like a giant kit. Over 15,000 bolts, each one hand tightened because they decided bolting it together would be a gentler way and a more precise way than welding it on site. The shape itself was inspired, depending on who you ask, by a Celtic double-headed X, or a ribcage of a whale, or a propeller of a ship. And I love that, because it tells you that the engineers weren't just solving a big problem, they were making history, and they knew it. In 2002, it opened, and Queen Elizabeth herself did the honors of opening it. And here's the thing, nobody fully predicted this. It didn't just reconnect those 2 canals, but it brought back life to the region. You see, Falkirk wasn't exactly a tourist hotspot. It was a town that industry had largely moved on from. And then suddenly there was this engineering miracle sitting right in the heart of it. And people came to see it. They still do. It's one of Scotland's biggest attractions. It's a piece of pure, marvelous engineering. And that's the part I never want to skip on this channel. Because we talk about tons and kilowatts and volts and whatever. But in the end, engineering is a craft done by people. It's the welder, it's the bricklayer, it's the designer. It's a town that got to host a world's first wheel. The Falkirk wheel. It isn't just impressive because it's big. It's impressive because a group of people decided that good wasn't good enough. It still turns today, every single day, quietly lifting boats into the sky on the energy of 8 kettles, balanced on a trick we borrowed from Archimedes 2,000 years ago. And just down the canal there are 2 30-meter steel horses standing guard over the waterway. But that, my friends, is a story for another day. And I'm really glad you're here for this one. There's too much in this world that gets built and then forgotten. So let's keep telling each other the stories of the people who refuse to settle. And I'll see you in the next one. Thank you very much.